Hello there, and welcome to Science Documentary for Sleep. Tonight, I'm going to spend some time with Saturn, its rings, its presence, and the steady facts we know about it. This is a long-form popular science documentary, told slowly and clearly, without any pressure to follow every detail. You can listen closely, or loosely. Nothing here needs to be memorized. Understanding can arrive gradually, or not at all, and that's perfectly fine. I'll be here either way, guiding the ideas forward at an unhurried pace. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. If you'd like, you can also share where you're listening from and what time it is for you right now. With that gentle orientation in place, let's begin. We move forward from that gentle beginning without needing to shift our pace. In the background of this conversation, Saturn already exists as a pale point of light, steady and distant. Imagine a dark sky where one object appears calmer than the rest, not brighter, just persistent. It doesn't flicker, it waits. Saturn is the sixth planet from the Sun, orbiting far beyond Earth and Mars, and even beyond Jupiter. Its average distance from the Sun is about 1.4 billion kilometers, placing it firmly in the outer solar system. At that distance, sunlight is weaker, cooler, and slower to arrive. This location matters because it shapes nearly everything about Saturn, from its temperature to its composition. Being far from the Sun means Saturn never became a rocky world like Earth. Instead, it formed mainly from hydrogen and helium, the lightest and most abundant elements available. As you listen, you don't need to picture exact distances. It's enough to sense Saturn as a planet that belongs to the colder, quieter regions of the solar system. From here, the view naturally widens. That wide view stays with us as Saturn continues to take shape in the mind. Picture a world without a solid surface, where clouds deepen instead of ground appearing. There is no place to stand, only layers. Saturn is classified as a gas giant, meaning it lacks a true solid surface. Beneath its visible clouds, pressure increases steadily, compressing gas into denser and denser states. Eventually, hydrogen behaves more like a liquid than a gas, and deeper still, it becomes metallic under immense pressure. This structure explains why Saturn's average density is remarkably low. In fact, Saturn is the least dense planet in the solar system. If there were a large enough body of water, Saturn would float. This isn't a trick fact so much as a consequence of physics. Hydrogen and helium dominate the planet, and heavier materials make up only a small fraction of its mass. For you, this means Saturn is less a place than a process, an ongoing balance of gravity and pressure, quietly holding itself together. With that internal structure in mind, Saturn's motion becomes easier to imagine. Think of a slow, steady path carved through space, repeating again and again without urgency. Saturn takes about 29.5 Earth years to complete one orbit around the Sun. A single Saturnian year is nearly 3 decades long by Earth standards. Seasons on Saturn therefore last more than 7 Earth years each. This long orbit results directly from Saturn's distance from the Sun. The farther a planet is, the larger its orbit and the slower its motion, according to well-established laws of planetary motion. Because of this, Saturn's seasonal changes unfold gradually. Shifts in sunlight across its hemispheres happen so slowly that they can be observed over years rather than months. As you hear this, there's no need to track time precisely. Saturn moves at a pace that doesn't demand attention, it simply continues, reminding us that many natural rhythms operate far beyond human schedules. That slow movement pairs with another defining trait. Imagine a planet turning gently, its clouds stretching into subtle bands as it spins. Despite its long year, Saturn rotates quickly on its axis. One full rotation takes just over 10.5 hours. This rapid spin causes the planet to bulge outward at the equator and flatten slightly at the poles, giving Saturn a visibly squashed shape. This effect, called oblateness, is common among fast-spinning planets. but it is especially pronounced on Saturn due to its low density and fluid composition. There is no rigid surface to resist the outward pull. The result is a planet whose shape reflects its motion directly. For you as an observer, this means Saturn is always in motion internally and externally, even when it appears calm through a telescope. Beneath that still appearance, rotation quietly reshapes the entire world. From shape, attention naturally drifts to appearance. Picture soft bands of colour, muted golds, pale browns, and faint whites wrapped around a distant sphere. Saturn's atmosphere is marked by horizontal cloud bands created by high-speed winds. These winds can reach speeds of over 1,800 km per hour near the equator, among the fastest in the solar system. The bands form because Saturn's rapid rotation organizes atmospheric motion into stable east-west flows. Differences in temperature and composition between layers create subtle color variations. Unlike Jupiter's bold contrasts, Saturn's colors appear gentler, partly due to a thick haze in its upper atmosphere that softens visual boundaries. You don't need to analyze those colors closely. It's enough to notice that Saturn presents itself quietly, not dramatically. Its atmosphere moves with immense energy, but it reveals that energy in restrained ways. As those atmospheric layers continue their motion, gravity holds everything in place. Imagine an invisible grip, steady and encompassing, extending far beyond the visible planet. Saturn's gravity is strong, but because of its low density and large size, it is slightly weaker at the cloud tops than Jupiter's. An object at Saturn's upper atmosphere would experience about 1.06 times Earth's gravity, only marginally stronger than what you feel now. This balance allows Saturn to retain its massive atmosphere without crushing it into a compact form. Gas remains extended, contributing to the planet's large volume. For you, this means Saturn's scale can be misleading. It looks immense, yet its gravitational pull is surprisingly familiar in strength. The planet doesn't overwhelm, it sustains. Gravity here acts more like a quiet agreement than a forceful command. That agreement between gravity, motion, and composition carries us gently onward. Picture Saturn as a system rather than a single object, already hinting at complexity beyond its clouds. Everything described so far, the distance, the low density, the rapid rotation, creates the conditions that allow Saturn's most famous feature to exist at all. None of it stands alone. Each property supports the next. This interconnectedness matters because it shows how planetary traits are not isolated facts but consequences of shared origins and physical laws. Saturn is not designed, it emerges. As you listen, you're simply accompanying these ideas as they line up naturally. No effort is required. The planet continues to turn, to orbit, to hold itself together. And without needing to pause or conclude, attention can drift outward, toward what surrounds Saturn as it moves through space. That outward drift continues naturally, without changing the tone or pace. Imagine Saturn no longer alone in space, but accompanied, moving with subtle complexity. The planet becomes the center of a wide, quiet neighborhood. Saturn possesses an extensive system of moons, more than 140 confirmed so far, ranging from tiny fragments only a few kilometers across to worlds larger than the planet Mercury. These moons orbit Saturn at varying distances and speeds, forming a layered system shaped by gravity and time. This abundance exists because Saturn's strong gravitational field captures and stabilizes objects that pass nearby, while its distance from the Sun reduces disruptive solar influence. The moons matter not as decorations, but as participants in Saturn's ongoing story. Each follows predictable paths, governed by the same physical rules that guide planets. For you, this introduces Saturn as a gravitational anchor. Not solitary, not crowded, just quietly influential, holding a complex system together as it moves forward. Among that system, one presence gradually draws focus. Picture a hazy, orange-tinted sphere wrapped in thick clouds that hide everything beneath. Titan is Saturn's largest moon and the second largest moon in the entire solar system. It is unique because it possesses a dense atmosphere, thicker than Earth's, composed primarily of nitrogen with traces of methane. This atmosphere creates surface pressure higher than Earth's and supports complex weather patterns, including clouds, rain, and seasonal changes. Titan's thick haze blocks visible light, making its surface difficult to observe without specialized instruments. What matters here is not Titan's mystery, but its familiarity. Nitrogen-rich air connects Titan conceptually to Earth, even though conditions are far colder. As you take this in, Titan doesn't demand comparison. It simply exists as proof that atmospheres are not exclusive to planets, expanding the idea of where complex environments can form. That idea settles gently as attention returns to Saturn itself. Picture faint arcs encircling the planet, thin at first, almost indistinct. Saturn's ring system is the most extensive and visible in the solar system, stretching hundreds of thousands of kilometers from the planet's equator. Despite their vast width, the rings are remarkably thin, typically only about 10 meters thick in many regions. They're composed primarily of water ice, with smaller amounts of rocky material. The high reflectivity of ice is what makes the rings appear bright when sunlight strikes them. This contrast, wide but thin, defines the rings' physical reality. They are not solid bands, but countless individual particles orbiting together. For you, this reframes what you're seeing. The rings are not objects you look at, but motions you witness, layered into a form that feels stable only from a distance. That motion continues uninterrupted, quietly precise. Imagine each icy particle following its own path, never colliding violently, never stopping. Every particle in Saturn's rings obeys the same orbital mechanics as moons and planets. Inner particles orbit faster than those farther out, creating constant relative motion within the ring system. This differential speed prevents the rings from clumping into a single body. Gravity pulls inward, motion pulls forward, and the balance keeps the structure extended. The rings endure not because they are rigid, but because they are dynamic. Stability here comes from movement, not stillness. As you listen, there's no need to visualize each particle. It's enough to sense that Saturn's rings are active systems, quietly organized by physics rather than held in place by any solid framework. From motion, attention drifts toward origin. Picture the rings not as ancient fixtures, but as something that has changed over time. Current evidence suggests Saturn's rings are relatively young, likely forming within the last 100 to 400 million years. This conclusion comes from measurements of ring mass and contamination by dust, which indicate they have not existed since Saturn's formation. One leading explanation is that the rings formed from the breakup of an icy moon or comet that ventured too close to Saturn and was torn apart by tidal forces. This matters because it places the rings within an ongoing timeline. They are not permanent features. For you, this introduces impermanence without drama. Saturn's most iconic trait is temporary on cosmic timescales, quietly reminding us that even stable-looking systems are subject to change. That sense of time deepens without requiring attention to dates. Imagine the rings slowly dimming, almost imperceptibly, as fine material drifts away. Saturn's rings are gradually losing mass. Micrometeoroid impacts and interactions with Saturn's magnetic field cause material to fall into the planet, a process known as ring rain. Over tens to hundreds of millions of years, this process will thin the ring significantly. Eventually, they may disappear entirely. This isn't an event to anticipate, only a process to acknowledge. Planetary systems evolve quietly, without milestones. For you, this fact exists without urgency. Saturn remains Saturn whether the rings shine brightly or fade. The planet does not depend on permanence to remain what it is. With that awareness, the view steadies again. Picture Saturn continuing along its orbit, rings intact for now, moons following their paths. Everything here, the moons, the rings, the slow loss of material operates simultaneously, without interference. No single process dominates. This layered calm is what defines Saturn as a system rather than an object. It is always becoming, never finished. As you remain with these ideas, there's nothing to resolve. They simply coexist. The planet moves on, carrying its companions with it, and attention can follow naturally, without effort, toward deeper structures and forces that remain quietly at work beneath the surface. That movement beneath the surface invites attention without asking for it. Imagine Saturn's clouds thinning as the view descends, not to a ground, but into pressure and heat. The planet becomes less visible and more physical. Deep within Saturn, hydrogen behaves in unfamiliar ways. As pressure increases with depth, hydrogen transitions from a gaseous state into a liquid, and deeper still into metallic hydrogen. In this form, hydrogen conducts electricity. This matters because metallic hydrogen is central to how Saturn generates its magnetic field, unlike Earth, where a solid core and molten iron drive magnetism. Saturn relies on this electrically conductive layer. The process is steady and continuous. There is no sharp boundary, only gradual change driven by pressure. For you, this offers a reminder that planetary interiors don't need solid ground to be active. Motion and energy can exist in states that don't resemble anything from daily experience. The descent doesn't end here. It simply slows, allowing the idea to settle. That internal motion extends outward, shaping invisible structures. Picture a vast magnetic bubble surrounding Saturn, stretching far into space. Saturn possesses a powerful magnetosphere generated by the movement of metallic hydrogen within its interior. This magnetic field traps charged particles and channels them along invisible lines that extend far beyond the planet itself. Unlike Earth's magnetic field, Saturn's is unusually symmetrical, closely aligned with its axis of rotation. This symmetry remains an active area of scientific interest because it differs from most planetary magnetic fields. What matters here is not the mystery, but the presence. Saturn's magnetosphere forms a protective and organizing structure around the planet. For you, this field is not something to feel or see directly. It exists as a quiet extension of Saturn itself, reaching outward, interacting gently with space, and continuing its work without interruption. Within that magnetic environment, light sometimes appears. Imagine faint curtains glowing near Saturn's poles, subtle and restrained. Saturn experiences auroras similar to Earth's northern and southern lights. These auroras occur when charged particles, guided by the planet's magnetic field, collide with gases in the upper atmosphere, causing them to emit light. The colours and brightness differ from Earth's auroras due to Saturn's atmospheric composition and magnetic conditions. But the underlying process is the same. These displays are not constant. They fluctuate with solar activity and internal dynamics. For you, the significance lies in connection rather than spectacle. Auroras reveal that Saturn participates in the same space weather processes that affect Earth. Different scale, same physics. The light appears quietly, then fades, leaving the system unchanged. As that light dissipates, attention returns to Saturn's atmosphere. Picture storms forming slowly, not violently, expanding across vast distances. Saturn hosts large-scale storms, including rare planet-wide disturbances known as Great White Spots. These storms emerge roughly once every Saturnian year, driven by seasonal heating differences deep in the atmosphere. When they appear, they can span tens of thousands of kilometers and persist for months. Their brightness comes from high-altitude ammonia ice clouds brought upward by powerful convection. What matters here is scale, not drama. These storms are expressions of energy redistribution within a massive atmosphere. For you, This reframes storms as long conversations between heat and motion, unfolding at a pace far removed from terrestrial weather. They don't rush, they grow, linger, and eventually disperse. Beneath storms, chemistry continues quietly. Imagine invisible reactions unfolding in cold, dense air. Saturn's atmosphere is composed primarily of hydrogen and helium, with trace amounts of methane, ammonia, and water vapor. These trace compounds play key roles in cloud formation and atmospheric color. Ammonia forms the upper cloud layers, while deeper clouds involve ammonium hydrosulfide and water. Temperature and pressure determine where each compound condenses. This layered chemistry explains why Saturn's appearance changes subtly with depth. Different materials reveal themselves only at certain levels. For you, this means Saturn's atmosphere is structured rather than uniform. It's organized by physics and chemistry working together quietly, producing patterns without intention or design. The complexity exists without calling attention to itself. Those chemical layers interact with sunlight slowly. Picture pale light filtering through haze, softened before it reaches deeper clouds. Saturn's upper atmosphere contains a thick photochemical haze formed when ultraviolet sunlight interacts with methane. This process creates complex hydrocarbons that scatter light. The haze reduces contrast in Saturn's cloud bands, giving the planet its muted, pastel appearance compared to Jupiter's sharper features. This isn't a flaw or obstruction. It's a natural outcome of chemistry responding to light. For you, the haze becomes a reminder that visibility is not clarity. Saturn is no less active because its features appear softened. Sometimes, complexity presents itself quietly, diffused through layers that invite patience rather than inspection. With that patience, the system feels whole again. Picture Saturn as layers within layers: interior, atmosphere, magnetic field, all moving together. Nothing here competes for attention. Each process supports the others, forming a continuous planetary rhythm. This matters because it shows how Saturn maintains balance across extremes of pressure, temperature, and scale. Stability emerges from interaction, not simplicity. For you, there's no need to assemble these facts into a single image. They don't demand coherence. The planet continues its slow rotation, its deep currents flowing unseen, its magnetosphere extending outward, and attention can remain with that motion, unhurried, as Saturn carries its complexity forward through space. That quiet motion through space remains unbroken as attention shifts outward again. Imagine Saturn not as a single body, but as a source of influence spreading gently through its surroundings. The space around it is not empty. Saturn's gravitational field shapes the orbits of nearby objects with remarkable precision. Moons, ring particles, and faint debris all respond continuously to this invisible structure. Gravity here is not abrupt. It fades gradually with distance, guiding motion rather than forcing it. This matters because it explains why Saturn's system remains orderly over long periods of time. Orbits persist not through rigidity, but through predictable balance. For you, this can exist as a background idea. Saturn does not need to assert itself. Its presence alone is enough to organize motion across vast distances. The planet continues forward, its gravity extending quietly, preparing the ground for subtle interactions that rarely draw attention. Within that gravitational reach, relationships begin to form. Picture two bodies moving in rhythm, never colliding, never drifting apart. Some of Saturn's moons exist in orbital resonances, meaning their orbital periods are locked into simple ratios with one another. For example, one moon may complete exactly 2 orbits in the time another completes 1. These resonances arise naturally from gravitational interaction over time. Small tugs accumulate, gradually adjusting orbits until stable patterns emerge. This matters because resonances help maintain long-term stability in Saturn's system. They reduce chaotic motion and distribute energy predictably. For you, this introduces harmony without intention. The moons are not coordinated, yet their movements align. Physics allows order to arise slowly, without planning or correction. That harmony extends into the rings themselves. Imagine narrow gaps carved into the rings, precise and persistent. Several of Saturn's ring gaps are created by gravitational resonances with nearby moons. As a moon repeatedly tugs on ring particles at specific distances, it clears out material, forming well-defined divisions. The most famous of these is the Cassini division, a wide gap maintained by resonance with the moon mimas. This process does not require forceful removal. Repeated gentle interactions are enough to reshape the system. For you, this reframes absence as structure. Empty spaces in the rings are not accidents. They are records of interaction, written quietly by gravity over long periods of time. Beyond gaps, some moons interact even more directly. Picture a small moon tracing the edge of a ring, guiding it without touching. Shepherd moons orbit near the boundaries of Saturn's rings, using their gravity to confine ring particles and maintain sharp edges. Their influence prevents the rings from spreading outward or inward too quickly. This role is subtle. The moons do not dominate the rings, they simply guide them. What matters here is restraint. Saturn's rings remain narrow and defined not because they are fixed, but because small bodies continuously adjust their motion. For you, this offers another example of balance without force. Stability arises from ongoing, gentle correction rather than control. As these interactions continue, motion never truly stops. Imagine the rings shimmering slightly as particles exchange energy. Collisions between ring particles are frequent but mild. Ice fragments bump and slide, redistributing energy without catastrophic impact. These collisions help keep the rings thin by dissipating vertical motion. Over time, particles settle into a flat plane aligned with Saturn's equator. This matters because it explains the ring's remarkable thinness. They are flattened not by pressure, but by countless small interactions. For you, this reinforces a quiet theme. Large structures can be shaped by very small events repeated patiently over time, without intention or awareness. That patience extends into measurement itself. Picture a spacecraft gliding past Saturn, listening rather than watching. Much of what is known about Saturn's gravity and internal structure comes from precise tracking of spacecraft motion. Tiny changes in velocity reveal variations in gravitational pull. These measurements allow scientists to infer mass distribution inside the planet and within the rings. This matters because Saturn reveals itself indirectly. Its interior cannot be seen, only sensed through effect. For you, this highlights a gentle method of knowing. Understanding does not require intrusion. Sometimes, careful observation of motion is enough to reveal what lies beneath. With that understanding, the system remains open and unfinished. Picture Saturn continuing its journey, its moons maintaining rhythm, its rings responding softly to gravity. Nothing here resolves into a final state. Motion continues, adjustments persist, and balance is maintained moment by moment. This matters because Saturn's system is not static. It is sustained through interaction rather than permanence. For you, there is no need to hold these ideas together tightly. They don't demand coherence. The planet moves on, carrying its gravity, its companions, and its quiet relationships forward, leaving space for attention to drift naturally toward what Saturn reflects about time itself. That sense of time begins to stretch naturally, without changing direction. Imagine Saturn not as it appears now, but as it has existed across long spans, quietly evolving. The planet carries its past with it. Saturn formed about 4.5 billion years ago from the same rotating disk of gas and dust that gave rise to the rest of the solar system. Gravity drew material inward, concentrating hydrogen and helium into a growing mass. As Saturn accumulated material, its size increased rapidly, allowing it to capture vast amounts of gas before the young sun dispersed the surrounding nebula. This matters because timing shaped Saturn's identity. Forming early allowed it to become a gas giant rather than a smaller rocky planet. For you, this places Saturn within a shared origin. The same processes that led to Earth's existence also produced a very different world, guided only by location and mass. The planet's history begins quietly, without ceremony, as gravity does its patient work. From that early formation, internal heat continues to linger. Picture warmth rising slowly from deep within Saturn, independent of sunlight. Saturn emits more energy than it receives from the Sun. This excess heat comes primarily from a process known as Kelvin-Helmholtz contraction, where the planet slowly compresses under its own gravity, converting gravitational energy into thermal energy. As Saturn contracts imperceptibly over time, heat is released and transported upward through its atmosphere. This matters because Saturn is not thermally passive. Even far from the Sun, it remains energetically active. For you, this reveals a planet that sustains itself internally. Saturn does not rely entirely on external input. Its warmth is a quiet consequence of its own mass and gravity, continuing long after formation. That internal heat influences motion above. Imagine convection currents rising and falling, invisible but persistent. Heat escaping from Saturn's interior drives convection in its atmosphere. Warm material rises, cools, and sinks again, creating large-scale circulation patterns. These motions contribute to the planet's wind systems and cloud structures, linking deep interior processes to visible atmospheric behavior. This matters because Saturn's atmosphere is not shaped by sunlight alone. Internal energy plays a constant role. For you, this connects layers that seem separate. What happens far below affects what appears far above. Even when the connection cannot be seen directly, Saturn behaves as a single system, not a stack of isolated parts. Time also leaves marks in subtler ways. Picture Saturn's tilt, steady but not extreme, guiding the slow change of seasons. Saturn's axis is tilted by about 26.7 degrees relative to its orbital plane. Similar to Earth's axial tilt, this tilt causes seasonal variations as different hemispheres receive varying amounts of sunlight during its long year. Over years, changes in illumination affect atmospheric temperature and circulation patterns. This matters because seasons on Saturn exist, even at great distance from the Sun. For you, this offers familiarity without sameness. Saturn shares structural traits with Earth, but expresses them on much longer timescales. Change occurs slowly, but it still occurs, shaped by geometry rather than intention. Those seasons interact with the rings as well. Imagine sunlight striking the rings at different angles, altering their brightness. As Saturn orbits the Sun, the angle of sunlight on its rings changes. During equinoxes, the rings are edge onto the Sun and appear much darker, sometimes nearly disappearing from view. This variation is purely geometric. The rings themselves do not change, only how light meets them. This matters because appearance can shift without substance changing. For you, this is a reminder that observation depends on perspective. Saturn's rings are constant in structure, yet their visibility fluctuates quietly as the planet continues its slow path around the Sun. Over longer periods, gravity asserts itself again. Picture Saturn's moons subtly reshaping their orbits over millions of years. Tidal interactions between Saturn and its moons gradually alter orbital distances and rotational states. Energy is exchanged through gravitational flexing, especially for larger moons closer to the planet. These interactions can cause moons to slowly migrate outward or inward over geological timescales. This matters because Saturn's system is not frozen in time. Orbits evolve, even when change is too slow to notice directly. For you, this introduces patience as a scientific necessity. Understanding planetary systems requires comfort with processes that unfold far beyond human lifespans. With that patience, Saturn settles again into continuity. Picture the planet moving forward, shaped by time rather than events, formation, internal heat, seasonal change, and orbital evolution all coexist without interruption. No single process defines Saturn. This matters because Saturn is best understood as duration rather than moment. For you, there's nothing to hold on to tightly here. These facts don't demand integration or recall. The planet continues, carrying its history quietly within it, and attention can remain with that steady movement, allowing the sense of time itself to stretch gently onward. That stretched sense of time remains present as the view becomes more observational. Imagine Saturn being watched not by people, but by instruments patient, precise, and distant. The planet does not respond, it simply continues. Human knowledge of Saturn changed significantly with the arrival of spacecraft. The first close flybys came from the Pioneer 11 probe in 1979, followed by the Voyager missions in the early 1980s. These encounters provided the first detailed measurements of Saturn's atmosphere, rings, and moons. What mattered most was proximity. Instruments could detect fields, particles, and structures that telescopes could only suggest. For you, this marks a shift in perspective. Saturn did not change, only our way of noticing did. The planet remained as it was, while understanding quietly expanded around it. That expansion continued steadily, without urgency. Picture a spacecraft settling into orbit, returning again and again to the same view. The Cassini spacecraft entered orbit around Saturn in 2004 and studied the system for 13 years. During this time, it repeatedly passed through the rings, flew close to moons, and monitored seasonal changes. Cassini's long presence mattered because it allowed slow processes to be observed directly. Patterns emerged only because time was given. For you, this introduces a different scale of attention. Cassini did not rush discoveries. It waited, measured, and returned. Understanding grew not through single moments, but through sustained observation. Within that sustained view, mass became clearer. Imagine Saturn's rings not just as light, but as weight. Cassini's precise tracking enabled scientists to measure the total mass of Saturn's rings more accurately than ever before. These measurements showed the rings are less massive than previously thought, supporting the idea that they are relatively young. This mattered because mass determines longevity. Lighter rings are more vulnerable to loss over time. For you, this shifts the rings from spectacle to substance. They are not only beautiful, they are measurable, finite, and subject to physical limits. Beauty here is a consequence, not a purpose. As mass clarified, structure followed. Picture narrow waves rippling through the rings, almost imperceptible. Cassini detected density waves within Saturn's rings caused by gravitational interactions with moons and with Saturn itself. These waves propagate through the ring material, encoding information about gravitational forces. By studying these patterns, scientists could infer details about Saturn's interior, including oscillations within the planet. This matters because Saturn reveals itself indirectly. Internal motion leaves signatures far from its source. For you, this shows how systems communicate across distance. A vibration deep inside Saturn can shape patterns hundreds of thousands of kilometers away, quietly linking interior and exterior. That communication extends to chemistry as well. Imagine sampling particles as they drift past, without disturbance. Cassini directly analysed material from Saturn's rings and atmosphere, identifying water ice, organic compounds, and trace elements. These measurements confirm the icy nature of the rings and provided insight into interactions between rings and atmosphere. This mattered because composition could finally be tested, not inferred. For you, this represents a gentle certainty. Saturn's materials are no longer abstract ideas. They are substances with measurable properties, behaving exactly as physics predicts, without requiring interpretation or belief. As the mission continued, endings approached quietly. Picture a spacecraft choosing its final path deliberately. In 2017, Cassini executed a planned series of dives between Saturn and its rings before entering the planet's atmosphere. This prevented contamination of moons like Enceladus and Titan. Cassini burned up, becoming part of Saturn itself. This mattered not as drama, but as closure. Observation gave way to protection. For you, this moment holds restraint rather than loss. Knowledge was gathered carefully, and the system was left undisturbed, allowing Saturn to continue without human presence. With the instruments gone, Saturn remains unchanged. Picture the planet once again unobserved, moving through space as before. Everything learned through exploration now exists separately from the planet itself, stored as data and understanding. Saturn does not carry our records. This matters because knowledge does not alter its subject. Saturn is not aware of being studied. For you, this creates distance without detachment. You can know Saturn deeply without needing to influence it. The planet continues its orbit, its rings circling, its moons maintaining rhythm, leaving attention free to follow the system forward, beyond observation, into broader context. That broader context opens gently, without shifting the tone. Imagine Saturn no longer isolated within its own system, but positioned among other giants, sharing space and influence. Saturn belongs to a group of planets known as the gas giants, alongside Jupiter, Uranus, and Neptune. These planets dominate the outer solar system by mass and volume. Saturn, while less massive than Jupiter, is still nearly 95 times the mass of Earth. This matters because Saturn's role is not minor. Its gravity contributes significantly to the overall structure of the solar system, influencing the motion of smaller bodies nearby. For you, this places Saturn within a larger family. It is not unique in type, but distinct in expression. Each giant planet follows the same physical laws, yet arrives at a different balance. Saturn holds its place quietly, neither central nor peripheral, simply present. Within that family, comparison arises naturally. Picture Jupiter and Saturn side by side, similar in scale but subtly different in character. While both planets are composed primarily of hydrogen and helium, Saturn contains a higher proportion of lighter elements relative to its size, making it significantly less dense than Jupiter. This difference affects everything from internal pressure to magnetic field strength. Jupiter's greater mass compresses its interior more intensely, while Saturn remains comparatively diffuse. This matters because small differences in formation lead to lasting divergence. For you, this shows how planetary identity emerges from degree rather than kind. Saturn is not defined by a single trait, but by how its properties combine softly rather than forcefully. That softness extends to Saturn's gravitational reach. Imagine the asteroid belt beyond Mars, shaped subtly by distant giants. Saturn, along with Jupiter, has influenced the distribution of asteroids and comets throughout the solar system. Its gravity alters trajectories over long periods, contributing to orbital stability and occasional disruption. These influences are not dramatic events. They occur through repeated minor adjustments accumulating over millions of years. This matters because Saturn participates in shaping regions far beyond its immediate vicinity. For you, this reframes influence as something gradual. Saturn does not need proximity to matter. Its presence alone is enough to guide motion at a distance. Beyond influence, Saturn also preserves records. Picture small icy bodies lingering in distant orbits, unchanged for ages. The outer solar system contains reservoirs of icy objects, such as the Kuiper Belt, whose stability is partly maintained by the gravitational configuration of the giant planets, including Saturn. These regions retain material from the early solar system, preserved by distance and cold. This matters because Saturn indirectly helps maintain cosmic memory. For you, this introduces a quiet continuity. The planet's gravity contributes to preserving ancient material, allowing the solar system to retain traces of its earliest conditions without intention or awareness. That preservation links Saturn to planetary formation elsewhere. Imagine distant stars surrounded by faint disks of dust. Observations of other star systems reveal ring-like and disk-like structures around young stars, shaped by gravity in ways similar to Saturn's rings and moons. These similarities suggest that the processes seen around Saturn are not unique, but common outcomes of planetary formation. This matters because Saturn becomes a reference rather than an exception. For you, this widens the frame. What unfolds quietly around Saturn may be happening elsewhere, beyond observation, following the same rules without variation or emphasis. With that wider frame, Saturn's rings take on new meaning. Picture them not as decoration, but as a scaled-down disk. Saturn's rings offer a nearby example of disk dynamics, allowing scientists to study processes that also occur in protoplanetary disks around young stars. Collisions, resonances, and wave patterns operate at vastly different scales, yet obey the same physics. This matters because understanding Saturn informs understanding far beyond it. For you, this links the immediate and the distant. A structure visible through a telescope reflects mechanisms shaping entire planetary systems elsewhere. That reflection settles without conclusion. Picture Saturn continuing its path, now understood as part of a repeating pattern. Nothing about Saturn demands uniqueness. Its value lies in clarity. It shows how familiar laws produce complex systems when given time and space. This matters because it allows understanding without wonder-seeking. For you, Saturn remains present without needing interpretation. The planet moves on, its rings turning, its gravity extending outward, quietly mirroring processes that unfold across the galaxy, leaving attention free to rest within that broader, unhurried context. That broader context remains steady as attention narrows slightly again. Imagine Saturn returning to the frame, not as comparison, but as a subject of careful measurement. The planet is distant, yet accessible through patience. One of Saturn's defining measurable properties is its size. Saturn's equatorial diameter is about 120,500 kilometers, making it the second largest planet in the solar system. Its immense width contrasts with its relatively low mass compared to Jupiter. This matters because size alone does not determine weight. Saturn occupies a vast volume while remaining comparatively light. For you, this can exist as a simple relationship. Saturn is large because its materials are spread out, not because they are tightly packed. The planet's scale reflects expansion rather than compression. The image holds gently, allowing that sense of breadth to remain without requiring comparison. That breadth becomes clearer when considering volume. Picture a hollow space filled with layered motion instead of solid matter. Saturn's volume is so great that more than 760 Earths could fit inside it, yet its mass is only about 95 times that of Earth. This disparity reinforces Saturn's low average density. The planet's interior is dominated by light elements arranged under pressure rather than heavy rock or metal. This matters because it explains why Saturn behaves as it does, why it spins quickly, bulges at the equator, and maintains an extended atmosphere. For you, this fact doesn't need visualization in detail. It simply offers proportion. Saturn is spacious rather than heavy, expansive rather than compact. With proportion established, rotation returns quietly. Imagine Saturn turning smoothly, clouds stretching along its path. Because Saturn lacks a solid surface, its rotation rate varies slightly by latitude. Different cloud layers rotate at different speeds, making it difficult to define a single rotation period. Scientists therefore define Saturn's rotation using measurements of its magnetic field and radio emissions, rather than visible surface features. This matters because Saturn resists simple timing. Its fluid nature prevents rigid reference points. For you, this suggests flexibility rather than ambiguity. Saturn's rotation is known, but it must be inferred indirectly, reminding us that not all systems reveal themselves in straightforward ways. That indirectness appears again in Saturn's core. Picture a dense center hidden beneath layers of pressure. Saturn is believed to have a core composed of heavier elements such as rock and ice, surrounded by metallic hydrogen. Unlike Earth's sharply defined core boundary, Saturn's core may be diffuse, gradually blending into surrounding layers. This uncertainty reflects the extreme conditions involved. Pressures are so high that materials behave in unfamiliar ways. This matters because Saturn challenges simple models. Its interior is not neatly divided. For you, this leaves room without frustration. Some structures remain partially known, not because of oversight, but because nature does not always form clear edges. Those unclear edges affect temperature as well. Imagine heat rising unevenly, without a single source. Saturn's internal temperature increases steadily with depth, reaching tens of thousands of degrees Celsius near the core. This heat contributes to convection and energy transport. Despite this internal warmth, Saturn's upper atmosphere remains extremely cold, with temperatures around -178 degrees Celsius on average. This matters because Saturn spans extremes without conflict. Heat and cold coexist, separated by distance rather than barrier. For you, this emphasizes scale. Saturn is not defined by a single climate, but by gradients that stretch far beyond everyday experience. Those gradients influence soundless motion. Picture pressure waves moving invisibly through dense material. Saturn exhibits global oscillations, subtle vibrations within the planet that affect its gravitational field. These oscillations were detected indirectly through patterns in the rings. They reveal that Saturn behaves like a resonating body, responding to internal processes. This matters because Saturn communicates internally, even without solid structure. For you, this introduces quiet complexity. The planet is not static inside. It hums softly through motion that leaves traces only for those who know how to look. With that awareness, the system feels layered once more. Picture Saturn as a body defined by inference as much as observation. Size, volume, rotation, and internal structure all emerge through careful measurement rather than direct sight. This matters because Saturn teaches patience in understanding. Not everything presents itself openly. For you, these facts don't need to be gathered or retained. They can simply pass through, leaving a sense of scale and continuity behind. The planet continues its steady motion, vast and diffuse, inviting attention to remain soft as the journey moves onward, without urgency or conclusion. That soft continuity holds as attention shifts towards Saturn's interaction with light. Imagine sunlight arriving from far away, weakened but persistent, spreading across a pale world. The light does not warm quickly, it reflects. Because Saturn is so distant from the Sun, it receives only about 1% of the sunlight that reaches Earth. The energy arrives diluted, stretched thin across space. This matters because Saturn's appearance is shaped more by reflection than illumination. The planet does not glow from heat or brightness, but from how efficiently it scatters light. For you, this establishes a quieter relationship with the Sun. Saturn is not bathed in light, it is outlined by it, revealing form without emphasis. The light arrives, touches the clouds and rings, and continues onward, leaving Saturn unchanged. That reflection is especially noticeable in the rings. Picture sunlight striking countless icy fragments, each responding briefly. Saturn's rings are highly reflective because they are composed primarily of clean water ice. Ice scatters visible light efficiently, making the rings appear bright even at great distance from the Sun. This reflectivity, known as albedo, allows the rings to stand out sharply against the darkness of space. This matters because the rings do not generate light, they return it. Their visibility depends entirely on angle and illumination. For you, This makes the rings feel responsive rather than assertive. They appear when conditions allow, then fade when light shifts, without changing their underlying structure. As light changes, shadows emerge. Imagine long, thin shadows cast across Saturn's cloud tops. Saturn's rings cast shadows onto the planet's atmosphere, creating dark bands that move slowly with the seasons. These shadows allow scientists to measure ring thickness and structure with precision. The shadows change length and position as Saturn orbits the Sun, providing a moving reference for geometry. This matters because absence of light becomes informative. For you, it shows that even darkness carries structure. Shadows are not voids, but measurements written quietly across Saturn's surface, revealing relationships without intrusion. Those shadows also fall upon the rings themselves. Picture one ring eclipsing another, subtle and precise. Mutual shadowing occurs when Saturn's rings block sunlight from reaching other ring sections. This effect reveals vertical structure and particle distribution. During equinox, when sunlight strikes edge-on shadows become especially pronounced, allowing detailed study of ring thickness. This matters because Saturn's rings are not perfectly flat. Small vertical variations exist, shaped by gravitational interactions. For you, this reinforces restraint. The ring's complexity is revealed only when light aligns just right. Nothing announces itself prematurely. Light also carries information beyond vision. Imagine wavelengths you cannot see passing through Saturn's atmosphere. By studying how Saturn's atmosphere absorbs and emits infrared radiation, scientists measure temperature, composition, and energy flow. Infrared observations reveal heat escaping from Saturn's interior and subtle variations across latitudes. This matters because Saturn communicates thermally as well as visually. For you, this expands perception gently. What you cannot see still contributes to understanding. Saturn exists across spectra, indifferent to how it is perceived. Radio waves offer another quiet channel. Picture signals passing through rings and atmosphere, bending slightly. Radio science experiments measure how Saturn's atmosphere and rings affect radio signals sent from spacecraft to Earth. These changes reveal density, particle size, and structure with high precision. This matters because Saturn is measurable without contact. For you, this suggests a non-invasive form of knowing. Information emerges from interaction rather than interference, preserving distance while increasing clarity. With light and signal accounted for, Saturn remains composed. Picture the planet illuminated from afar, defined by reflection, shadow, and subtle emission. Nothing here demands focus. Light arrives, is altered, and moves on. This matters because Saturn's visibility is conditional, not intrinsic. For you, the planet does not insist on being seen. It continues its path through dim sunlight, its rings responding quietly, leaving attention free to drift onward toward the quieter boundaries where Saturn meets the surrounding space. That boundary with surrounding space approaches without sharpness. Imagine Saturn's atmosphere thinning gradually, not ending, simply giving way. There is no clear edge, only transition. Saturn does not have a solid surface where atmosphere abruptly stops. Instead, its gases become progressively thinner with altitude, blending into space over thousands of kilometers. This matters because Saturn's surface is a convention rather than a physical boundary. Scientists define it by pressure levels, not material. For you, this softens the idea of a planet as a contained object. Saturn fades outward rather than stopping, reminding us that many natural systems resist clean borders. The planet remains present even as it becomes less tangible. Within that fading region, particles still move. Picture atoms escaping slowly, one by one, into surrounding space. Saturn experiences atmospheric escape, where lightweight particles at high altitude gain enough energy to drift away into space. This loss is extremely slow, occurring over immense timescales, and does not threaten the planet's overall atmosphere. This matters because even massive planets exchange material with space. For you, this suggests openness rather than erosion. Saturn is not losing itself, only participating in a gradual exchange that links it to the wider environment. That exchange is shaped by Saturn's magnetic reach. Imagine charged particles being guided gently along invisible paths. Saturn's magnetosphere interacts with the solar wind, deflecting most incoming charged particles while channeling some toward the poles. This interaction shapes the outer boundary of the magnetosphere, compressing it on the sun-facing side and stretching it away on the opposite side. This matters because Saturn is not isolated from the sun's influence, even at great distance. For you, this becomes a quiet dialogue rather than a confrontation. Forces meet, adjust, and move on without conflict. Between Saturn and its moons, space is active. Picture streams of particles flowing along orbital paths. Some of Saturn's moons, particularly Enceladus, contribute material to the planet's magnetosphere by ejecting water vapor and ice particles. These particles become ionized and spread along magnetic field lines, forming a diffuse plasma environment around Saturn. This matters because moons and planets share material. For you, this blurs boundaries again. Saturn's system behaves less like separate objects and more like a shared environment in motion. That shared environment evolves quietly. Imagine the magnetosphere adjusting as conditions change. Variations in solar activity subtly alter the size and shape of Saturn's magnetosphere, affecting particle motion and auroral activity. These changes are continuous, not episodic. This matters because Saturn's space environment is responsive rather than fixed. For you, this reinforces a calm adaptability. Systems respond without strain, maintaining balance through flexibility rather than resistance. Beyond the magnetosphere, Saturn's influence fades. Picture gravity loosening its grip, gently releasing space to move freely at great distances. Saturn's gravitational pull becomes negligible compared to that of the Sun. Objects there are no longer bound to the planet. This matters because Saturn's domain is finite, even if it feels vast. For you, this offers proportion. Influence does not need to be endless to be significant. Saturn shapes what lies near, and then allows distance to take over. With that release, the system feels complete yet open. Picture Saturn centered within layers of diminishing influence: atmosphere, magnetosphere. Gravity all extend outward, then taper naturally. This matters because Saturn ends not with a line, but with a gradient. For you, there is nothing to resolve. The planet continues onward, interacting softly with its surroundings, leaving attention free to remain at that boundary where presence fades into space, without finality or demand. That open boundary lingers as attention turns inward again, without reversing direction. Imagine Saturn as a system that leaves traces of itself, subtle markers carried far beyond the planet. One such trace is Saturn's gravitational imprint on passing objects. When spacecraft fly by Saturn, their trajectories shift slightly, gaining or losing speed through gravitational assist. This process follows strict physical laws and conserves energy across the system. Saturn gives momentum without losing its own orbital stability. This matters because Saturn participates in motion beyond itself. Its gravity becomes a tool, not a barrier. For you, this shows Saturn as cooperative rather than obstructive. It shapes paths without resistance, allowing movement to continue smoothly through its presence. The planet remains steady as motion bends gently around it. That bending of paths applies to natural objects as well. Picture a comet passing through the outer solar system, its route quietly altered. Saturn's gravity can redirect comets and icy bodies, changing their orbits over long periods of time. Some are nudged inward toward the Sun, others outward toward distant space. These changes rarely happen all at once. They accumulate through repeated distant encounters. This matters because Saturn acts as a long-term sculptor of motion. For you, this reframes chance encounters as gradual processes. A single pass means little, but time allows small influences to become lasting changes. Those redirected objects carry material history. Imagine icy bodies preserving ancient chemistry as they move. Comets influenced by Saturn often contain primordial material from the early solar system. Their composition reflects conditions present during planetary formation. When Saturn alters their paths, it indirectly redistributes this ancient material across the solar system. This matters because Saturn participates in mixing history. For you, this suggests that planetary influence extends beyond gravity alone. Motion carries memory, and Saturn helps decide where that memory travels. Within Saturn's own system, memory exists too. Picture cratered surfaces on distant moons, unchanged for ages. Many of Saturn's smaller moons show heavily cratered terrain, indicating surfaces that have remained largely unaltered for billions of years. These craters record impacts from earlier periods of solar system history. This matters because Saturn's environment preserves records through stability. For you, this introduces stillness within motion. Even as the system evolves, some surfaces remain as quiet archives of past events, untouched by erosion or renewal. Other moons tell a different story. Imagine a surface that renews itself, erasing its past. Some of Saturn's moons, such as Enceladus, show relatively few craters, indicating ongoing geological activity. This resurfacing replaces older terrain with new material, resetting visible history. This matters because Saturn's system contains both preservation and renewal. For you, this balance exists without contrast or tension. Different outcomes emerge from different internal conditions, all within the same gravitational family. That family relationship shapes motion over time. Picture moons adjusting their rotation slowly. Most of Saturn's major moons are tidally locked, meaning they rotate once per orbit, always showing the same face to the planet. This state results from long-term tidal interactions that dissipate rotational energy. This matters because time aligns motion. For you, this offers a quiet image of synchronization. Without intention or effort, motion settles into predictable patterns, guided by physics alone. With that synchronization, the system feels settled yet active. Picture Saturn and its moons moving together, each following its role. Gravity maintains structure, while time allows adjustment. This matters because Saturn's influence is patient rather than forceful. For you, there is no need to assemble a narrative. The planet continues its steady course, its influence carried through motion and memory, leaving attention free to remain with that gentle continuity as the system unfolds further. That gentle continuity remains as tension settles on Saturn's moons more closely. Imagine a collection of worlds moving quietly through shared space, each shaped by the same central presence, yet developing differently over time. Saturn has an unusually diverse set of moons, varying widely in size, composition, and activity. Some are irregular fragments, while others are large, spherical bodies with complex internal structures. This matters because diversity arises naturally within a single system. Saturn's gravity does not produce uniform outcomes. For you, this allows difference without hierarchy. Each moon exists as a result of its position, mass, and history, not as a lesser or greater companion. The system holds variety gently, without forcing similarity. Among these moons, ice dominates. Picture surfaces composed not of rock and soil, but of frozen water and other volatiles. Many of Saturn's moons are composed largely of water ice mixed with rock. At the temperatures present in the outer solar system, ice behaves as a structural material, forming crusts and landscapes. This matters because ice here plays the role rock plays on Earth. For you, this shifts familiar categories. Solid ground does not require warmth. Stability can emerge under cold conditions just as readily, shaped by different materials responding to gravity. That icy composition allows internal motion. Imagine warmth trapped beneath a frozen shell. Some of Saturn's moons retain internal heat, generated by radioactive decay and tidal interactions with Saturn. This heat can maintain subsurface oceans beneath icy crusts. Enceladus is the clearest example, with evidence of liquid water beneath its surface. This matters because liquid environments can exist far from the Sun. For you, this widens the frame of possibility. Conditions thought to be rare may arise quietly wherever energy and material align, without needing Earth-like settings. That internal water sometimes reaches the surface. Picture fine jets of vapor escaping through cracks in ice. Enceladus ejects plumes of water vapor and ice particles from its south polar region. These plumes feed Saturn's E-ring and reveal the moon's internal composition. The activity is driven by tidal heating as Enceladus flexes under Saturn's gravity. This matters because motion generates energy. For you, this presents activity without violence. Enceladus does not erupt explosively. It releases material gently, continuously, responding to gravitational rhythm. Other moons remain quiet by comparison. Imagine a smooth, ancient surface, unchanged for long spans. Moons such as Rhea and Dione show less geological activity, preserving older terrain shaped mainly by impacts. Their stillness reflects lower internal energy and weaker tidal effects. This matters because inactivity is also an outcome. For you, this reinforces that motion is conditional. Not every body needs to evolve actively. Stability can persist when forces remain balanced and minimal. Size plays a role in these outcomes. Picture a spectrum from small fragments to large spheres. Larger moons retain heat more effectively and experience stronger tidal forces, increasing the likelihood of internal activity. Smaller moons cool quickly and remain inert. This matters because scale shapes destiny without intention. For you, this shows how simple physical relationships produce varied results. Size alone can determine whether a world changes or remains still. With these differences in view, the system feels layered again. Picture Saturn's moons not as a group, but as individual responses to shared conditions. Each follows the same laws, yet arrives at a different state. This matters because Saturn's system demonstrates diversity without complexity of rules. For you, there is nothing to resolve. The moons continue their orbits, some active, some quiet, all held gently within Saturn's gravitational presence, allowing attention to remain soft as the system unfolds onward. That unfolding continues without change in pace or intention. Imagine Saturn's system as a laboratory shaped entirely by natural law, repeating the same experiments over immense spans of time. Nothing is adjusted, nothing is corrected, because Saturn and its moons form together from the same region of the solar nebula. They share similar initial materials. Differences emerge later, shaped by distance, size, and interaction rather than origin. This matters because variation does not require different beginnings. The same starting conditions can lead to many outcomes. For you, this removes any sense of exception. Saturn's system did not require special circumstances. It followed ordinary rules, given time and space to express them fully. The planet and its companions continue quietly, illustrating divergence without disruption. Distance plays a central role in that divergence. Picture moons closer to Saturn moving through stronger gravitational gradients. Moons that orbit closer to Saturn experience stronger tidal forces, leading to internal heating and orbital evolution. Those farther away feel weaker effects and remain more static. This gradient creates a natural spectrum of activity within the system. This matters because placement matters as much as composition. Where a body exists shapes what it becomes. For you, this reinforces a gentle principle. Outcomes are influenced by position, not by intent or design. Saturn's system unfolds spatially, not hierarchically. Those spatial differences influence orbital shape. Imagine some moons moving in near-perfect circles, others slightly stretched. Most of Saturn's major moons have nearly circular orbits, a sign of long-term gravitational stabilization. Minor deviations persist where resonances or past interactions occurred. Circularization occurs as energy is dissipated through tidal interactions over time. This matters because time smooths motion. For you, this introduces a quiet erosion of extremes. Orbits settle not through control, but through repetition, gradually minimizing irregularity. Inclination adds another subtle variation. Picture orbital planes tilted just slightly relative to Saturn's equator. While many of Saturn's moons orbit close to the planet's equatorial plane, some exhibit inclined or retrograde orbits. These moons were likely captured rather than formed in place. Capture occurs when gravitational interactions slow an object enough to bind it to the planet. This matters because Saturn's system includes both native and adopted bodies. For you, this allows inclusion without uniformity. Saturn's gravity does not discriminate by origin. Objects remain if motion allows them to stay. Those captured moons often appear irregular. Imagine shapes that are uneven, fractured, and asymmetric. Irregular moons tend to be small and distant, with non-spherical shapes reflecting weak self-gravity. Their surfaces preserve impact history without internal reshaping. This matters because shape reflects energy. Without sufficient mass, bodies cannot reorganize themselves. For you, this makes form understandable. Geometry is not imposed. It emerges from balance between gravity and material strength. Material strength varies with composition. Picture ice behaving differently than rock under stress. In Saturn's environment, ice is rigid at low temperatures but can deform slowly under pressure. This allows larger icy moons to become spherical, while smaller ones remain irregular. This matters because material properties shape planetary outcomes. For you, this introduces quiet adaptability. The same substance can behave differently depending on context, without changing its nature. With these layers aligned, Saturn's system remains open. Picture gravity, distance, material, and time operating together without hierarchy. No single factor dominates. Each contributes gradually to the system's present state. This matters because complexity emerges without instruction. For you, there is nothing to synthesize. The planet continues forward, its moons arranged by circumstance rather than plan, allowing attention to remain light as the system carries on, quietly consistent and unfinished. That sense of being unfinished stays with us as attention drifts toward change yet to come. Imagine Saturn not only as it is now, but as it will quietly become, shaped by processes already underway. Nothing sudden, nothing dramatic. Over billions of years, Saturn will continue to cool. Heat will escape gradually from its interior as gravitational contraction slows. The planet's internal energy will diminish, though never abruptly. This matters because planets age without milestones. Saturn does not switch states. It transitions slowly, almost imperceptibly. For you, this reframes change as something continuous rather than event-based. Saturn is already becoming its future self, simply by continuing to exist. That cooling affects motion deep inside. Picture convection currents slowing, stretching out over longer times. As Saturn loses internal heat, the convection that drives some atmospheric motion will gradually weaken. Wind speeds and storm activity may reduce over extremely long timescales. This matters because energy availability shapes expression. When less energy moves upward, motion softens rather than stops. For you, this introduces a future that does not erase the present. Saturn will remain active, but more quietly, guided by the same rules operating more gently. The rings are part of that future as well. Imagine the rings thinning almost beyond notice. As ring material continues to fall into Saturn through ring rain and micrometeoroid erosion, the rings will lose mass. over hundreds of millions of years, they may fade significantly or disappear entirely. This matters because even Saturn's most iconic feature is temporary. For you, this does not diminish the planet. Saturn existed long before the rings formed and will continue long after they're gone. Identity here is not tied to appearance. Moons will respond in turn. Picture their orbits shifting slightly, measured in millimeters per year. Tidal interactions will continue to alter the distances between Saturn and its moons. Some moons may drift outward, others inward, depending on energy exchange. This matters because motion never truly stops. For you, this reinforces patience as a scientific requirement. Meaningful change often unfolds far beyond immediate perception. Beyond Saturn itself, the solar system will evolve. Imagine the sun slowly brightening as it ages. Over billions of years, the sun's increasing luminosity will alter conditions throughout the solar system, including at Saturn's distance. Temperatures will rise modestly even in the outer regions. This matters because Saturn's future is tied to the sun's. For you, this places Saturn within a shared destiny. No planet exists independently of its star. Systems age together. Eventually, the solar system will change profoundly. Picture Saturn orbiting a sun that no longer resembles its current form. As the sun enters its red giant phase billions of years from now, its outer layers will expand dramatically. While Saturn is likely to survive, its environment will change significantly. This matters because permanence is never guaranteed. For you, this does not introduce urgency. It simply extends the timeline. Saturn's story is long enough to include transformations that are almost impossible to imagine. With that distant future acknowledged, attention returns gently to the present. Picture Saturn as it is now, complete for this moment. Past formation, current motion, and future change coexist without conflict. This matters because understanding does not require closure. For you, there is nothing to anticipate or resolve. Saturn continues its steady orbit, existing fully in the present, even as time moves quietly through it, leaving space for attention to remain calm and open as the journey nears its final stretch. That calm openness remains as the view widens one final time, without signaling an ending. Imagine Saturn simply continuing to exist, not as a subject of study, but as a presence within the larger pattern of the universe. Nothing about it asks to be finished. Saturn is one example of how matter organizes itself under gravity, motion, and time. The planet does not represent a goal or outcome. It represents a state, one that exists because conditions allow it to. This matters because Saturn does not need interpretation to be meaningful. Its existence alone demonstrates how physical laws express themselves at scale. For you, this removes pressure. There is no message to extract. Saturn does not instruct or warn. It simply persists, following the same rules as everything else. That persistence is quiet rather than absolute. Picture Saturn as temporary, but long-lived, balanced between formation and dispersal. Like all planets, Saturn exists within a finite window of cosmic time. It formed, it evolves, and eventually it will change beyond recognition. This matters because duration does not imply permanence. Saturn lasts not because it resists change, but because change unfolds slowly. For you, this allows acceptance without loss. The planet's significance does not depend on how long it remains as it is. Its presence now is sufficient. Within that duration, Saturn remains indifferent to observation. Imagine the planet moving whether or not it is seen. Saturn does not become more real when observed, nor less real when ignored. Telescopes, spacecraft, and data do not alter its behavior. This matters because knowledge exists separately from its subject. Understanding is something humans carry, not something Saturn receives. For you, this creates space. You can learn without needing to affect what you learn about. Observation does not require intervention. That separation allows gentler attention. Picture Saturn as something you can return to or drift away from without consequence. Facts about Saturn do not demand retention. They remain available whether remembered or forgotten. This matters because understanding is not a test. For you, this means nothing is lost if details fade. The planet does not recede when attention softens. It continues unchanged. Saturn also exists beyond human categories. Imagine it without names, without labels, without comparisons. Before it was called Saturn, before it was identified as a gas giant with rings, it was already there. This matters because classification is a tool, not a property. For you, this invites release. Concepts can be set down without diminishing what they describe. Saturn remains present even when language falls away. With concepts loosened, only motion remains. Picture Saturn orbiting the Sun, rings turning, moons following their paths. No part of the system pauses, no part completes itself. This matters because continuity does not need resolution. For you, this offers a place to rest attention without expectation. The system does not lead anywhere, it simply continues. And so the view holds, open and unfinished. Picture Saturn as one steady movement among countless others, neither central nor insignificant. Nothing needs to be concluded, nothing needs to be remembered. This matters because understanding can remain partial and still be enough. For you, awareness can drift or remain alert, both equally welcome. Saturn continues on its path, and attention is free to stay with that quiet motion, or to move elsewhere without any need to decide. The ideas can remain exactly where they are now, without being gathered or closed. You might feel awake, or quietly reflective, or somewhere in between, and all of that fits. Nothing here was meant to be carried forward or held in place. Saturn continues whether it's being thought about or not, and the same is true of these thoughts themselves. They don't need to settle into meaning. They can stay loose, incomplete, or drift away entirely. If attention lingers, that's fine. If it moves on, that's fine too. The system remains unfinished, and so does the listening, open to whatever comes next.